Let's talk about the scaling of a graph. And let's start with an example. Let's start with this one. How about y equals x squared? We know what that one looks like, the parabola. I'll draw a picture right over here. So we know it starts right here at the origin, and then you square whatever horizontal you make, you square it. That'll give you the vertical. So what do? We go 1 in each direction. We go up 1, over 2, up 4, over 2, up 4, over 3, up 8, over 3, up 8. And let's try to draw a decent curve through all those points. Maybe it looks like this. Not too bad. Now, visually, here's what this equation says. Y, that's a vertical. That's a vertical distance. And this is, x is a horizontal. So think of it like this. What this says here is that the vertical movement that you make is the horizontal movement you make squared. So the vertical is the square of the horizontal. And you can see that going on over here, right? Look over here now. What if we start here and we make a horizontal movement of 2? Then the vertical is the square, right? If we make a horizontal movement of 2, we would get 2 squared, which should be our vertical, is 4. Now, let's do an example of scaling. Let's maybe take a look at this as an example. 1/2 x squared. Now, what this says in terms of verticals and horizontals is that the vertical movement that you make is 1/2 of the horizontal squared. So your vertical is going to be 1/2 of the square of the horizontal. Let's get a picture of that. So why don't we start at the origin here. And here's what I'm going to do. I'm going to change this, say, by 2. Right? So make a horizontal movement of 2. I square it, I get 4, and then I take half of that. So what we might get here is this. If x equals 2, then what do you get for y? Y is equal to 1/2 of 2 squared. So y is equal to 1/2 of 4. Y is equal to 2. So look where we are then. We'll start right here at the origin. I'll make a horizontal movement of 2. That's my horizontal movement of 2. Then I'll square it. That gives me 4. But then I take half of that. So I'm at half of 4, which is 2. So if I graph this, we would be right here. Now I'm going to do the same thing if I go to -2. Go 2 in the left. So -2, that's our horizontal. I go 2 to the left, I square it, I get 4. Take half of 4, I'm at 2. So I'm going to get this point right here. Now let's see what happens out here at 4. Okay? If x equals 4, then, all right, y is equal to 1/2 of 4 squared. Y is half of 16. Y is equal to 8. So let's get a picture of that. So what I would do is I go out 4, and then 4 squared is 16. Half of 16 is 8. That's going to put me here. So let's draw that in. And if I go the other direction to -4, right, if I go out to -4 and square that, I'll get 16. Half of that is 8, so I'll put a point here. Let's draw a curve through those points. See what we can do here. Pretty good. All right, so what I'm seeing is this. I start with this basic curve, y equals x squared. If I multiply it by 1/2, it seems like we have stretched the curve out, like we have done something like this. I've taken this curve here and like stretched it out. Okay, I'm kind of flattening it. Let's try even another one. I'll erase that and we'll come back up here. How about if we had this? 1/4 x squared. So what this tells us, right, if you just read it and try to translate it into words, it says the vertical movement, that's y, your vertical movement is 1/4 of the square of the horizontal movement you make. So let's try this here. Now we have to be a little bit careful so we get decent numbers here. What if we do this? Say we start here, if x is equal to 2, then we'll get this. Y is equal to 1/4 of 2 squared. Y equals 1/4 of 4. Y equals 1. So let's plot this point here. We're going to move from the origin 2 units to the right, and then our horizontal squared is 4. Take 1/4 of that, so we're at a vertical of 1. We'll plot that point right here. Over 2, up 1. We're right here. And if I go 2 in the other direction, I'm at -2. I square it, I get 4. Take 1/4, I'm still at 1. Now let's go out to 4 again. So what happens if x is equal to 4? Then the vertical, y, is equal to 1/4 of 4 squared. Y is equal to 1/4 of 16. Y is equal to 4. So let's plot that point. We're going to start at the origin, go horizontal of 4, and then a vertical of 4, right? Because the vertical is 1/4 of the square of the horizontal. So let's plot that. So we're going to go out to 4, and then up 4. That puts us right over here. Can you see it? And I'll do the same thing to the left. I'll go out 4, square getting 16, take 1/4 of it. That gets me at 4. Let's draw a curve the best we can through these points here. We'll come down to a smooth curve at the bottom. Bring it through and up. Not too bad. So let's compare this green curve to our original. So here's our original. Now this is y equals x squared. If I put a multiplier out here, 1/4, what it does, it tends to, we call it compress. It compresses this curve like toward the x-axis, right? It's like you're taking your hands, putting them on this red curve and pulling it down toward the x-axis. Now in the first two scaling examples, the scaling factors were fractions. They were between 0 and 1. Now let's try a number bigger than 1. So what if we keep it simple and just go with this? Y equals, now not just x squared, that's the red curve, but now we try 2x squared. So if I read this in terms of movements, this says, y, that's the vertical. The vertical is 2 times the square of the horizontal. Or whatever horizontal I make, I square it, and then I double that, and that'll give me my vertical. So let's try something here. Suppose x is equal to 1. Then y is going to be 2 times 1 squared. Y is equal to 2. So let's plot this point, right? We're going to make a horizontal movement of 1, and that'll give us a vertical movement of 2. Let's see if it's true up here. Make a horizontal movement of 1, you square it, you still get 1. You double that, now you're at 2. So let's plot that point. So we'll start at the origin. We'll go over 1 and then up 2. So let's put a point there. I'll put it in this color here. And then it's symmetric, so I'll go to the left one. Now, if I'm still making a horizontal movement of 1. I square it, multiply by 2. We're right here. And the origin is still right here, because if you put in 0, right, 0 squared is 0. 2 times 0 is 0. Now, what happens here if x is equal to 2? Well then, y is equal to 2 times 2 squared. Y is equal to 2 times 4. Y is equal to 8. So this is going to go up quickly. So if we just start at the origin, move a horizontal distance of 2 units, our vertical distance will be 8 units to get us back on the graph. Let's plot that point. We'll start here at the origin. We'll go to the right 2 and then all the way up to 8. So I'll plot that point over 2, up 8, and then by the symmetry, if I go to the left 2, I'm still up 8. Okay, I think that's all we can do here. Let's draw a curve between those, through those points. So let's see if we can pass a curve through these points. That looks reasonable. There, up, catch that one. Okay, I think we got it here. Okay, so look what happened here now. I made a multiplier of a number bigger than 1, and look what it did to that red curve. It's like we pulled it up now. We pulled it up. Like I said, you take your hands on the red curve and pull up. So the multiplier was bigger than 1, and we pulled it up. Now, if the multiplier was less than 1, see what happened? Right, these two curves were like grabbing it and pulling it down. So pulling it down is called compressing, or a compression. And pulling it upward, that's called a stretch. So we're going to either stretch it with a multiplier bigger than 1, or we're going to compress it with a multiplier less than between 0 and 1. Now, this is on page 233. I'll put that page up here if you want to look at it. Page 233, you'll find this rule. This rule summarizes what we just did. So here's what it says. Let's see if we can get through this definition with all the symbols. It says, compared with the graph of y equals f of x, all right, that would be our basic graph. So in that case, this is our red graph, our basic function f of x, and ours is x squared. Then the graph of a times f of x, so you put a multiplier on it. Now we had multipliers of what? 1/2, 1/4, and then we went to 2. Okay, where a is not 0, you don't want to multiply by 0. Then you just have y equals 0. All right, so compared with the graph, the basic graph, the graph of a multiplier times f is, okay, so number 1 says this, you get a stretch. Now a stretch vertically means you go up. That was like our, whatever color that is. So if what? You stretch vertically, if the absolute value of a, that means the number you're looking at is positive. If your multiplier is positive and bigger than 1, then you're going to stretch it upward. It's going to like tighten it, right? You take the basic curve and just like pull it and stretch it upward like this. So if your multiplier is, that's positive, makes it positive, and it's bigger than 1, then you get a stretching upward. Now our example was this one. Here's the one we did. We had a stretch when we did y equals, what did we have? 2x squared. That was our stretch. Now what happens, this is number 2, what happens if your multiplier is, all right, so take a positive number, but if that positive number is between 0 and 1, like we did 2, right, we had 1/2 and 1/4, then you get a compression vertically by that factor. Now the ones that we looked at were these, right? So we had a compression. We had this, we had y equals 1/2 x squared, and we had y equals 1/4 x squared. Now in this case, let's read this. Sometimes when you toss those absolute values in there, it's like it's too much to read. But here's what that says. What is the absolute value of 2? It's positive. I just want to ensure that this is a positive number. So I put an absolute value on it, ensure it's positive. So if the multiplier is bigger than 1, you're going to have a stretching. So if your multiplier is bigger than 1, like this one, you're going to have a stretching. So your basic curve, well, we can do better than that. So your basic curve is going to be stretched upward like this one. Okay, you take this one and stretch it upward. And now if your multiplier is a positive number between 0 and 1, like 1/2 or 1/4, 1/3, 5/6, something like that, then what you do is you get a compression. So here's your basic curve. Well, let's draw that one in yellow. So your basic curve is this one here. And then what happens is that you now get a compression, so it's now like expanded. It's just like it's widening. And if that was maybe like a half, if you take a 1/4 or a 1/5 or something smaller, it compresses it even more. So you're taking it and compressing it downward toward the x-axis. There's one more thing to look at down here. That's number 3. That's a reflection. Let's do that in the next video.